Hey everyone, welcome to today's lecture on robot specifications. When you're picking out a robot for industrial, medical, or research purposes, understanding its specs is a big deal. These specifications tell us all about the robot's performance, capabilities, and limitations. So let's dive in and break down the key specs of robots, why they matter, and how they impact different applications. Let's get started. First off, robot specs give us the nitty-gritty details about the robot's design, movement, and operating limits. The big ones to watch are payload capacity, degrees of freedom, work envelope, accuracy and repeatability, speed, power source, and control system. Alright, let's break these down one by one, starting with, that's the max weight a robot can lift and move around. It's usually in kilograms or pounds. For example, robots in assembly lines might handle a light load of 5 to 10 kilograms. But those in car manufacturing can heft over 500 kilograms. Picking the right payload capacity means the robot runs smoothly and doesn't wear out too fast. Next up, this is about how many independent movements a robot can make. Think of each joint or axis as adding 1 degree of freedom. A basic Cartesian robot might have 3 DOF, moving in X, Y, and Z directions, while a fancy robotic arm could have 6 or more DOF for more intricate tasks. More DOF means the robot can handle complex jobs like surgery or welding in tight spots. Then there's this defines the three-dimensional space where the robot can move. It depends on the structure and joints of the robot. Different robots have different work envelopes like Cartesian, cylindrical, spherical, articulated, or SCARA. Choosing the right one ensures the robot can reach all the points it needs to. Let's talk. Accuracy is about how close the robot gets to the programmed spot, and repeatability is about hitting that spot over and over again. For high-precision tasks like semiconductor manufacturing or precision welding, high repeatability within +0.02 mm is crucial for good quality. Now, V of a robot. This measures how fast it moves from one position to another, usually in meters per second or degrees per second for rotations. Fast robots are great for packaging or assembly lines because they cut down cycle times, but in places like robotic surgery, slower and controlled speeds are necessary for safety and precision. Robots need a 2. They can be electric, hydraulic, or pneumatic. Electric robots are common for their efficiency and control, hydraulic ones are used for heavy-duty tasks, and pneumatic robots are quick and good for lightweight tasks. D is like the robot's brain, running the programmed instructions. Robots can be controlled with teach pendants, offline programming, or real-time sensors and AI. Advanced robots use machine learning and vision systems to adapt, making them perfect for tasks like autonomous navigation or quality checks. Don't forget which let robots connect with networks and other devices, and like emergency stops, collision sensors, and protective barriers to keep everyone safe. Understanding these specs helps you pick the right robot for the job, whether it's in manufacturing, healthcare, or research. Matching specs to the task ensures the robot performs well and reliably. To wrap it up, remember the key specs: payload capacity, degrees of freedom, work envelope, accuracy, speed, power source, and control system. These determine the robot's fit for various tasks and industries. Thanks for watching. If you found this lecture helpful, like, share, and subscribe for more educational content. See you in the next session.